Okay, so in this video I'm going to have a look at another proof by induction, and this time I'm going to have a look at another inequalities example. So we're going to have a look at this particular inequality here. 1 plus 3x to the power of n is greater than or equal to 1 plus 3nx, and we're saying here as well that x is positive, and we're going to prove that this is true. So as usual, we first look at P1 and we see if that's true. So let's see if we can do that. So we have 1 plus 3x to the power of 1 on the left hand side. On the right hand side we've got 1 plus 3 times 1x, so that will give us 1 plus 3x on the left hand side and 1 plus 3x on the right hand side. So P1 is true. It is greater than or equal to it. In fact, it's equal to, so it is greater than or equal to, so that's true. Okay, so let's have a look at the next part then. Usually what we do is make an assumption here, so we'll just write that down. And our assumption here is that pk is true. So we're going to do pk. Now pk will just mean that we're going to put in a k here instead of n. We're going to assume it's true for some number k. So in other words, 1 plus 3x to the power of k is in fact greater than or equal to 1 plus 3kx. And again, remember that x here is greater than or equal to 0. So this is our assumption here. We're assuming this is true. And if this is true, can we prove that pk plus 1 is true? So let's see if we can do that. So we want to prove that, let's see, 1 plus 3x to the power of k plus 1 is greater than or equal to 1 plus 3 times k plus 1x. Okay, so the way we're going to do this is we're going to look at the left hand side and see if we can just rearrange that. So let's look at the left hand side first. Now the left hand side is 1 plus 3x to the power of k plus 1. Now that's really just, we can rewrite that as 1 plus 3x to the power of 1 times 1 plus 3x to the power of k. By the laws of indices, you know, you just add the powers here and you'll get the power here, which is k plus 1. Now looking at this here, this is what we want to prove is that this here is greater than the right hand side here first. Now what we can do here is in fact say that that is greater than or equal to 1 plus 3x times 1 we've got 1 plus 3kx here. How did I get that? Well, if you go back to our assumption again here, you can see that 1 plus 3x to the power of k, which is actually here, is greater than or equal to 1 plus 3kx, which is actually here. So these two parts here are, this part here is greater than this part here. Now really all this whole thing is we've multiplied the left hand side by 1 plus 3x and the right hand side by 1 plus 3x. So it's still greater than, the left hand side is still greater than or equal to the right hand side. Because all we've done is taken our assumption, if you like, and put a 1 plus 3x here and a 1 plus 3x here. Now we've done that using the left hand side of what we want to try and prove. So we've taken this here, split it up here, and we know that this will be greater than this right hand side here, greater than or equal to it. Now if we can show then that this here is greater than or equal to this part here, our pk plus 1 proposition, then this part must also be greater than it, because if this is greater than this and this is greater than this, then this must be greater than this here. So let's do that then. We're just going to multiply out the right hand side here of this here. We're just going to take this here and we're just going to multiply it out. So that will give us, let's see, I'll just change colors here again, I think. So we're just going to take this and multiply it out. So we have 1 plus 3kx, 1 plus 3kx plus 3x plus 9kx squared. So that's all of this here multiplied out. Okay, now if we can show that this is greater than this here, that's what we want to do. So what we want to do is look at is, we'll just write is here, is 1 plus 3kx plus 3x plus 9kx squared, is that greater than or equal to this here, which is just 1 plus 3kx plus 3x. I've just multiplied out this bracket here. So if this is greater than this, then this must be greater than this here. So let's have a look and see if we can do this. Okay, so let's see. We have a 1 on the left hand side and we have a 1 on the right hand side. So we can subtract 1 from both sides. We have a 3kx here. We have a 3kx here, so we can subtract that from both sides. We have a 3x here and a 3x here, so we can subtract that from both sides. So what we're left with here is 9kx squared greater than or equal to 0. Okay, now is this greater than 0? Is 9kx greater than 0? Well, let's see. Our 9 here, we can divide both sides by 9 if you like, so we just get kx squared here, so that's fine. We can, let's see, what else can we do? The x squared is going to be positive anyway, isn't it? So we can divide, the x is, we were told at the beginning, x is positive, so obviously when you square any natural number, it's going to be positive, so that's positive. And our k here as well is going to be a natural number. K is an element of n, so that's going to be positive as well. So this is true. Okay, so k is greater than or equal to 0 if you like here. X squared is greater than, x is greater than 0, so x squared is greater than 0. So that's fine. We have shown that pk plus 1 in fact is true. So we can say then that pk plus 1 is true if k is greater than or equal to 0. Okay, so we can just finish that off then by just saying that by induction, by induction, 1 plus 3x to the power of n is greater than or equal to 1 plus 3nx. So by induction, that's greater than that. It is true for x greater than 0 if x is positive, and n of course will be an element of n. And we can say this since P1 is true, the proposition is true for 1, and also pk plus 1 is true if pk is true. And that's it really.